Okay, so how to identify an even or odd function. So here's your definitions. A function is even if f at negative x gets you an output of f at x, the original function, for all of the x's in the domain. And the function is odd if when you substitute negative x into the function, you get the negative function, so negative f at x for all x's in the domain of f. So what the heck does that mean? Sometimes the sentence doesn't quite translate very well to what's actually happening. So let's just come up with a function. So let's say it's f at x equals x cubed. Okay? Is this function even or odd? Well, it actually isn't too bad of a thing, of a process. Basically, to test it, you're just going to plug in negative x into the function. So if you plug negative x into x cubed, you'd have negative x to the third power, which is negative and then x cubed. And so, since this is a negative version of the original function, if you look back to the original, we know that this is an odd function. Okay, so there's an example of an odd function. So let's do an even. Let's try another one. Let's try it again with a different function, which will just so happen to be negative. So we'll call it g because we're on another function. So another function, g at x. Let's just test the absolute value at x. Is that even or odd? Well, the absolute value, so again, plug in negative x. And what happens is you got the absolute value of negative x, which is, if you apply the absolute value to it, it is the same as the absolute value of x, positive x. So that one, since we ended up with the original function, with what we started, this is an even function. Okay. All right, and you could also have the possibility that it's neither of the cases. So I'm guessing I'll just pick one that's neither. So I'm just going to pick a function. Oh, let's say it's x squared plus 2x minus 1. So I'm just picking any old function, and we're going to test to see if it's even or odd, or maybe neither. And so when you plug in negative x, we would have negative x squared plus 2 times negative x minus 1. And you simplify that all out, and you'd have x squared positive minus 2x minus 1. So this would be a neither. If you look at the original equation, a negative version of that would be we would have had to have come up with negative x squared minus 2x plus 1. Essentially change all the signs. Well, that didn't happen. We ended up with a positive x squared, a negative 2x, and this negative 1 stayed the same. So in this case, it also didn't come up with the original function. If you would have came up with the original function, we'd have been even. If we'd have came up with this one, we'd have been odd. But as it turns out, we've come up with neither of them. So this is neither an odd or an even function. And so that's it. That's the definition of even and odd. Now, if I'd have had just x squared by itself, or maybe x to the fourth, so let's maybe call this j at x equals x to the fourth power. Let's see if that is even or odd. Or we can make it even a little more complicated, equals 2x squared. So let's test this one. So when we test this one, not g, sorry. When we test this with j at negative x, keep it the same. You'd have negative x to the fourth power plus 2 times negative x squared. You simplify that, you'd have positive x to the fourth power, because negative times negative times negative times negative is positive. And then same goes here, you'd have positive 2, negative x times negative x is positive x squared. And so we'd have x to the fourth plus 2x squared. And we've come up with the original function, so this is an even function. Okay. And that's even and odd function. I could give you example after example, but if you come up, when you substitute negative x in and you come up with your original function, it's even. If you substitute negative x in and you come up with a negative version of the same function, it's odd. And if you substitute negative x and you don't come up with either of them, well then it's neither odd nor even. I could do one more example. So let's say we had p at x equals 2x cubed minus 3x to the fifth power. Okay? And I plug in my negative x into the function. So we'd have 2 times negative x cubed minus 3 times negative x to the fifth. And negative to the third power is negative, so that'd be negative 2x cubed plus, and hold on, I probably should, okay, I probably better, instead of just throwing that plus out there, you'd have negative 3 times, a negative, negative x 5 times, you keep going, negative, 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 there's positive and a negative, so you got positive times negative, so it's negative. Well, you've got a negative out here in front, so 2 negatives makes it positive. And then you'd have x to the fifth power. And so what we've ended up with, if you look at the original, the signs are exactly switched. So that's positive now and that's negative now. But if you notice, now we have opposite signs. It's the same as taking a negative of the original, a negative of 2x cubed minus 3x to the fifth. So a negative version of the original, if you distributed the negative through, would be negative 2x cubed plus 3x to the fifth, which is what we have. Therefore, this is an odd function. You can probably start to see the pattern of an even and odd function just by the examples I was giving you. Hope this helps. If you have questions, make sure you post them or ask. I want to know if these videos are helping. If they're not, please let me know. See you next time.